Okay, so here's what calculus is all about, what you're going to be doing for the next 3 months. This is a parabola, so just the blue, that's a parabola, okay? What calculus is about is developing an equation that will tell us the slope of the parabola at any point in time, okay? So what we use is a tangent line. So this red line is a tangent line, and a tangent line is when it touches your line just once. Does that make sense? That's a tangent line. So as you can see here, I know how to figure it out. You will learn how to figure this out. The slope of that line right specifically now is -2. Physicsy people, you would understand that that's a velocity. So as something's traveling in the air, the velocity at that specific point of time at 1 second is -2. What's happening as I move here? What's happening to the slope of that line? It gets steeper. Okay? What do you think about the slope of the line here? You know, right at the top. What do you think the slope of the line would be? 0, right? Okay, what's going on with the slope specifically over here? Now it's positive, right? So I can figure out with calculus what the slope of the line is at any point in time, and you're going to learn how to do that, okay? And in a physicsy world, that would be telling us the velocity of the object. Okay, so what we're going to do today is we're going to learn how to use a secant line. So this is now a secant line because it's going to touch in 2 places. Okay? Do you know how to figure out a slope with 2 points? Have you done that before in math? Slope using 2 points, right? Rise over the run of those 2 points would tell us the slope, which will tell us a velocity. Our goal is to make the distance between those 2 points essentially no distance, and if there's no distance between those points, it would become a tangent line. Okay? So our goal is to decrease this distance so that eventually it becomes a tangent line. Okay? So we're going to use limits, and we're going to say, oh, now I lost my point. Can't get my point back. Okay, so if I have my 1 point there and I want to figure out the slope specifically at 1, okay, all I'm going to do is I'm going to say the distance between these 2 points, the distance, and I'm going to get closer and closer and closer to 0. As the process gets closer to 0, it's going to get more accurate to being specifically at the 1 spot, the 1 point. Does that make sense? The distance between the points, we're going to get closer and closer to 0 distance away, so those points are now not 2 points. Hopefully they'll eventually be closer to just being 1 point. Okay? So we need the x space between them is going to get closer to 0. So in your notes package, I'm just reinforcing kind of the visual of something. So again, here's a function, which is a parabola, y equals x squared. So if I want to know the slope exactly at 1, this is what it would look like, okay, which is called a tangent line. So here's a secant line. So you can see right here, I took a point. Look at how much x space there is between those points. Okay, look at all the x space that I have between those points. So the slope of that is not that close to the above picture, right? The slope of that line is not that close to that. So now look at the space I put between the points now. I reduced it. Would you say the slope of that line is a little bit closer to the above picture now? It's getting closer, right? Then look at what I did. I made that x space even closer yet. Would this slope of this become more accurate yet? It's getting closer and closer to being what I want in the above picture. Okay, so our goal is to make that x space get closer to 0 so that there's no space eventually between them. Okay, does that make sense? So here's the definition of a derivative. So a derivative is that finding slope. So calculus is all about derivatives, and the word derivative is the thing that we're going to use to find slopes. So here's what we're going to do. Slope is y2 minus y1 over x2 minus x1. That's something you learned in grade 10, right? This was the rise, and that's the run. Okay, and that came from right? That's what we would do. We would have two coordinates. Does that ring a bell from grade 10? You'd always have two coordinates, and then you would take away their y's and take away their x's to figure out the rise and the run. Okay, so now we're going to put that into a functional notation. So instead of using x comma y, I might use x comma f of x. Does that make sense? Instead of y. And on the second coordinate, we're going to go x plus h. And what does h mean? It means that little bit of space, that x space. We're adding a little bit, and we don't want that little bit. Eventually, we want that little bit to be 0, right? Okay, so that's what's going to happen. So this example that I have out here is for the equation y equals x squared. So you can see what I did here. Y equals x squared. So instead of x squared, I wrote x plus h squared as my y2. Okay, that's what I did. X plus h squared minus the original. And then you can see here x plus h minus the x. x2 minus x1. Okay, algebra. I canceled that. I GCF'd the h out. And then I can cancel. And now I can plug in a 0, and so there's the equation for the slope, okay? All right, we're going to get into that. Okay, so here we go. Okay, so use this definition to find the slope. Okay, so let's go point 1 would be x comma 2x squared. Point 2 is now x plus h, right? Because we want the second point to be a little bit of space away, comma 2x plus h squared. So the original uses an x value, the second point uses an x plus h amount value. Okay, so give me a slope formula. So y2 minus y1 over x2 minus x1. Okay, what's the point of this? We're going to do the limit of this as the h space gets closer to 0, because we don't want space between those 2 points. That's the goal. Okay, now it's just algebra. Okay, so I need you to square that. So your first step is to square that.
Why did it turn just to h?
Because I did an x, subtract an x. So I did that part. Yeah. And that actually is always going to happen. And because that happens, look at this. This is why I can't plug a 0 in, right? You can't do the plug in. You can't put a 0 in that equation, right? Okay, so I next would distribute. Your next should be your 2x squared minus 2x squared, right? That should go. Next algebra is a GCF on top, right? You see that? Next algebra is a cancel. And now you're ready to apply the limit. I can plug 0 in now, right? I couldn't up here because I had to divide by 0, but now I don't have that problem. So what happens to this if I plug in a 0 for h? I get 4x. So that's the equation for the slope. Okay, so look at this. Y equals 2x squared. It looks like that, right? So what does that tell me? It tells me I can plug in any x value, and the slope would be 4x. So here's an example. At the x value of 1, what's the slope of that line hitting it? 4. At the x value -2, if my x value was -2, what would be the slope of that line at that point? The slope would be -8. And that is exactly what calculus is. Okay? Does that make sense? All right. So let's try an equation now with a fraction in it. Okay, so point 1 is x comma 24 over x. Point 2 will have an x value of x plus a little bit, which means this would be 24 over x plus a little bit. A little bit of space. H is always the little bit of space. Okay, so now we want the slope. So y2 minus y1 over x2 minus x1. And what's the point of the slope? We want to do the limit of this as that space between the points gets to be nothing. And once it's nothing, we have the actual slope exactly at a point. Okay, so what kind of algebra would we do if we are dealing with fractions like that? What would be the algebra behind fractions? What should you do if you're subtracting two fractions together? What do you need? Common denominator. So I'm going to need an x plus h and an x in a denominator together so that we can combine them, right? See, that's a common denominator. Okay, so what would I have to times this fraction by? X. And what would I have to times this fraction by? X plus h. Okay, so 24x minus 24x plus h. Okay, obviously we understand we can't plug a 0 in because that's a problem, dividing by 0. Okay, algebra here. 24x minus 24x minus 24h. Don't forget, right? Just distribute that as a negative. Okay, now here's the next thing I'm going to do. 24x minus 24x, I can get that out of there. Are you okay if I times and flip? So instead of dividing by h, I'm going to times by the flip. that okay? And now, guess what? What can you do? You can cancel an h. Eventually, the whole process to this is always that you're going to have to cancel an h so that we get rid of that divide by 0, right? I'm officially ready to plug in the 0 now. I got rid of my problem. As soon as you've got that canceled h out, now I can plug in. So what if you plug a 0 into this position? What does your bottom become? So that's me plugging a 0 in at that point. That's what I always do at the end. Okay, so now you're going to do it with a radical. So on your test, I have the 3. You're going to have one as a polynomial, one as a fraction, and one as a radical. Okay, so here we go. Point 1 is x comma 18 root x. So point 2 is x plus a little bit, 18 root x plus a little bit. Okay, so now we're going to do the slope. y2 minus y1 over x2 minus x1. What does the limit reach as the space between the points gets to nothing? Okay, so we knew the algebra with polynomials is just to expand. We know the algebra with fractions is to get a common denominator. So what's the algebra strategy, do you think, with radicals? It's a weird word. Starts with a C. Conjugates, yeah. Radicals, conjugates. Okay, so what's the conjugate of that? Remember what a conjugate is?
No.
It's the opposite sign. Are you also okay on the bottom here if I'm scratching those X's off?
I'm not, oh, because it's subtract. Never mind.
Yeah, X minus X, so I'll just make them go away. Okay, ooh, what is 18 times 18? 324. Okay, so 324. What happens when you do a radical times its own radical? Then the radical just goes away, right? Root x plus h will make it x plus h. When you do conjugates, what's the deal with your FOIL?
FO.
Don't even worry about OI. So forget that. So what's last times last? So plus minus will always make a minus. 18 is 324. What's root x?
Okay.
Just x. And then you know what you can do on the bottom? Just leave it alone. Just rewrite it. Okay, are you okay if I just rewrite that as a distribution right there? 324x plus 324h, right? What happens on the top there? The x's would be just go away. So 324h over look at this, we got to our goal. Our goal is always to get a canceled h, right? Because that's that problem. Divide by a 0 is the problem. Okay, we're ready to plug in, right? At this point, if I have that h gone, this is where I'm ready to plug in. So what does it become if there's no h there?
18x, no, 18 plus 18.
So is that 36 root x's? Right, 18 plus 18? Or, you know what else you could do? You could go 9 over root x, because that does divide. Okay, that's it. It's the same strategy. You're going to have the 3 types: polynomials, fractions, and radicals. I'm debating if I want to tell you the shortcut.
What if,
No,
What?
don't tell us it.
if you do root x plus root x, it's just root x?
If you do a root x plus a root x, that would be 2 root x's.
Okay.
If you do a root x times a root x,
Oh, yeah, I
then
see.
that's a x. Is that what you're thinking? Do you want to know the shortcut just to check
No.
your answers?
Yeah, let's do it.
Because you have to show me this. 'Cause- and the next unit is all about the shortcuts.
Tell us the shortcuts next week. I don't
Or
want
do you want to
Yeah,
do
I
shortcut?
don't-